Hi students, in this video we are going to learn a topic that is called ionization potential or ionization energy. What is this ionization potential or ionization energy? See, we already know as per the Bohr-Buris atomic model, protons and neutrons are located at the center of atom. Electrons revolve around the nucleus in definite circular paths. Those definite circular paths are n is equal to 1 k shell, n is equal to 2 l shell, n is equal to 3 m shell, n is equal to 4 n shell. If you consider n is equal to 4 n shell is the outermost shell, means last shell, that is called valency shell. The outermost shell of an atom is called valency shell. The electrons which are present in the valency shell is called valency electrons. Valency electrons. See, when an atom is participating in the bond, sometimes atoms are ready to lose electrons, sometimes they are ready to gain electrons. This loss or gain of electrons takes place only in the case of valency shell. That means only valency electrons are responsible for the bond formations. Either it may be ionic bond or covalent bond or coordinate covalent bond. This means in the case of bond formation, valency electrons are playing a very important crucial role. Sometimes they are ready to lose, means atoms are ready to lose electrons. Sometimes atoms are ready to gain the electrons. That are only in the case of valency shell. But the electrons does not come outside easily. Why? Because there will be a nuclear attraction out there on the electrons. Means the protons, which is a positive charged particle, always drag the electrons towards itself. The nuclear attraction on the valency electrons is one of the factors. Now, we want to remove this electron. To remove this electron from this valency shell, we should supply some amount of energy. Why we are supplying energy from outside? Why? Because the electron should overcome the nuclear attraction. That means if you supply some amount of energy to the electron which is there in the valency shell, what happens? It overcomes the nuclear attraction, then automatically it will jump outside from its valency shell. This means the amount of energy required. Why? To remove the electron from the valency shell of a neutral gaseous atom is called ionization potential or ionization energy. Why the word ion is came now? Let us explain with an example. If you consider sodium, where Z is equal to 11, atomic number is 11, and its electronic configuration is 1s2, 2s2, 2p6, 3s1. There only one valency electron is there in the sodium. I want to remove this electron from the valency shell of sodium. In this case, there are 11 protons and as well as 11 electrons are there in the neutral sodium atom because atomic number is 11. If we remove one electron, means sodium, neutral sodium with 11 electrons, 11 protons, you are ready to lose one electron. Now here how many protons are there? 11 protons, but the number of electrons are 10. What does it mean? There is a 1 unit positive charge is more when compared to number of electrons. That can be represented like this, Na1 plus. What does it mean? Sodium ion, because it is a positive charged particle, has 1 proton more when compared to number of electrons. Now, a neutral sodium atom becomes a sodium ion by the loss of electrons. To remove these electrons, we should supply some amount of energy. That means, whenever if you supply some energy to the valency electron of a neutral atom, then the electron will be ejected outside, then the neutral atom becomes ion. That amount of energy which is required to convert one neutral atom into its ion is called ionization energy or ionization potential. Now, we are going to discuss what is meaning of uni-positive ion. For example, say if we consider magnesium, where the atomic number Z is equal to 12. This means it has 12 protons and 12 electrons in its neutral atom. If the neutral magnesium loses one electron from its valency shell, means we are supplying some amount of energy to the valency electron of magnesium. First only one electron will come outside. Now what happens? 12 protons with 11 electrons. Means which charge is more? Positive charge is more. How many units it is more? 1 unit is more. So it can be written as Mg1 plus. Now this ion with positive charge is called, positive charge is 1. So further it is called uni-positive ion. The amount of energy what we supplied, that is called IP1. Ionization potential or ionization energy 1. Now Mg1 plus, this is nothing but uni-positive ion with 12 protons but with 11 electrons are there. If it is ready to lose one more electron, for that purpose again we should supply some amount of energy. Then IP1, now here it becomes 12 protons but with 10 electrons. Now in this case of the magnesium, which charge is more? Positive charge is more. How many units it is more? 2 units it is more. So it can be represented as Mg2 plus. See here, magnesium with positive charge, that will be 2 units are there. For that sake only that is called di-positive ion. This di-positive ion, we should supply some amount of energy, that is called ionization potential 2. That simply we are calling as IP2. The amount of energy required to convert a neutral gaseous element into uni-positive ion is called ionization potential 1. The amount of energy required to convert uni-positive element into di-positive element or di-positive ion is called ionization potential 2. Let us compare now which one is greater, IP1 or IP2. Absolutely IP2 is greater than IP1. If we consider aluminium, where atomic number is 13 with 13 electrons and as well as 13 protons. First of all, if it is lose one electron, now what happens? It becomes Al1 plus with 13 protons but 12 electrons. This energy is called IP1. As it lost one electron, the attraction process of the nucleus on the valency electrons becomes more because positive charges are more. Means Al1 plus with 13 protons, 12 electrons, ready to lose one more electron. For that purpose we should supply some amount of energy, that is called IP2. But IP2, that is nothing but energy what we are supplying to remove the electron from uni-positive ion. We should supply more than previous because the more number of protons attract the electrons towards itself. This means nuclear attraction is increasing, atomic size gradually decreases. As the size is decreasing, the nuclear attraction will be more. For that purpose, you should supply more amount of energy. Now it becomes Al2 plus with 13 protons but 11 electrons are there. Now this is called di-positive aluminum ion. Uni-positive aluminum ion, di-positive aluminum ion. Now the di-positive aluminum ion with 13 protons, 11 electrons, ready to lose one more electron, that is nothing but IP3. Ionization potential 3 is very high when compared to the IP2 and the all. Now it becomes Al3 plus with 13 protons but 10 electrons. Means aluminum is ready to lose more number of electrons, then automatically it becomes a tri-positive ion. Uni-positive ion, di-positive ions and tri-positive ions. Here if we can consider IP3 is greater than IP2 is greater than IP1. Let us come to know the units of ionization potential. They are kilojoule per mole or electron volt per atom. These two are the units of ionization potential.